Hello, welcome to episode 3 of Introduction to Matlab, Scilab, and Octave. Today we're going to talk about arrays. Now, basically every variable in Matlab or any of the others is an array. If it just has one element, it's called a one-by-one array. But what we'll learn in this episode is scalars, row vectors, column vectors, matrices, how to create them, what the conjugate transpose operator does, the colon operator, the size and numel functions. But like I said at the beginning, it might not be obvious, but every variable in Matlab is an array. Scalars. Scalars are quantities that can be represented as a single number. Technically, there's some more to it, but that's really what it is. If you type x equal 4 into Matlab, it creates a scalar m that contains the value 4. Scalars are subsets of matrices that only have one row and one column, a one-by-one matrix. And when we say an n-by-n matrix, we mean that it has n rows and m columns. Matrix is a synonym for array, so that's how that works. Row vectors. Row vector is laid out horizontally. This is an example of an expression that creates a row vector. If you look at the, you say A equals, the square bracket means the beginning of an array, 1, comma. The comma means a new element in that row, 5, comma, or 2, comma, 5. Creates a row vector. So the comma is used when the values are in the same row. So you can access the elements of an array using parentheses. That's called indexed. So you can say A parentheses 1 will give you the first element of A, which is 1. So in this case, you're taking the first element and you're setting equal to 1. Second element setting equal to 2. Third element equal to 5. This does the exact same thing as this statement here. So this is how you can display an element of an array. And now we're going to do a little bit of a demo. Okay, back to Octave. So let's do that example. A equals 1, 2, 5. Oops. 1, 2, 5. And that's what it gives you. I can say, now, this is a statement that you might try clear all. We'll clear all the variables out. So now I'll say A1 equals 1. A2 equals 2. A3 equals 3. You notice that the vector grows each time I index it by 1. That's something you probably don't want to do. So what you might want to do is use the colon operator to pre-allocate how much space you want in your array. So if you do this, you go A 1, 3 equals 0. So that creates a 3-element array. All the elements are 0. And then you can do A equals 1, A1 equals 1, A2 equals 2, and A3 equals 5, and it gets the same result. The reason why you do this step first, like in a real script, is just because it goes faster. You pre-allocate the memory required for that array, and then you set things equal to that. Otherwise, it has to move memory around as the array gets bigger, which slows down your code. Now, what does this colon operator do? So if you do, 2:7, it'll give you all the numbers between 2 and 7, all the whole numbers between 2 and 7. you can actually go, so what if you wanted to do 1.55 to 3.5? It'll do that too. It just increments by 1. So these are all row vectors. So another thing you can do with the colon operator is you can skip. So let's say you want to do what's 1, let's see, 1, 2, 7. So that, with 2 colons, the first number is the starting number, the second number is the step number, and the third number is the end number. Now, if you do 1, 2, 8, let's say 8, it gives you the same result because you can't go the last one was 7. 7 plus 2 is 9, which is above 8, so it won't do that because it has to be in that range. But you can also do it by, you can also create an array of things that are equally spaced. Like if you wanted to do something, like if you wanted to say set time over 1/10 of a second interval for I don't know, 60 seconds, you can go, well, okay, I want to go from 0 to in 0.1 steps to, I don't know, 60 seconds. That creates a big array, well, not that big array, 601 element array. Let's see, let's clear all again. So yeah, you can do anything. You can do, now this one thing about arrays, if you try to do something like this, so the subscripts must start from 1. They don't start from 0. Other programming languages, the subscript of arrays start at 0, notably C and C++, and a few others, well, a lot of others, but in Matlab, array, the bottom index array has to be 1. You can also, let's say you have an array, let's you make a new array with 10 elements in it. You can also set a subset of the array equal to something. So you could say I don't know, 3 to 7 is equal to 5. Whoops, of course, 5. And then it will put that subset of indices will be equal to 5. Okay, next things are column vectors that we're going to copy. Column vectors, as it implies, are a set of numbers laid out vertically. The semicolon now is used to indicate a new row inside the square brackets. This expression here, a equals 3 semicolon 2 semicolon 5, creates a column vector. You can also use the parentheses like you did before. You can also create a column vector by using a square bracket over multiple lines. Okay, so now we're going to go back to Matlab. Okay, so now we're going to clear all, which clears out all the variables from the workspace. And we're going to say a equals 2 semicolon 6 semicolon 9, just some random 3 numbers, and that creates a column vector. The other way you can do it is like I showed before, but it's hard. Let's see, I don't know if it'll work in the command line. Actually, I never tried that. Oh, that seemed to work. Okay. In a script you can do that and it makes more sense. Okay, so let's create a new vector. So we can still do this. Let's say 1 to 3 equals 0. Now if they're all real numbers, the way you can turn that into a column vector is by using this transpose conjugate operator, which is the single quote, and that turns it into a column vector. Now we're going to get to the transpose conjugate thing in a minute, but that's how that works. Okay, so now that you have some vector, you might need to know how big it is. So the size function returns a row vector that describes the size of a matrix. If size returns a two-element vector, the first number is the number of rows and the second number is the number of columns. In particular, if x is scalar, size of x returns row vector 1, 1, which means it has one row, one column. If y is a row vector, size y with 4 entries will return 1, 4. Column vector, here's one with 7 entries, size that will give you 7, 1. So let's see how that works, the size function. Notice when I do clear all, there's the workspace here. It shows all the variables that are currently in memory. When you clear all, they go away. Okay, Matlab has something similar. Let's say A125 equals 0. What is the size of A? So it's one row, 5 columns. So you can also use size to get whatever index you want. For instance, size A1 will give you how many rows. Size A2 gives you how many columns. Now, if this was a multi-dimensional array where you have more than 2 indices, then the row vector that has the size increases. So if you had like I won't go into how you make like a 1 by a 2 by 3 by 5 array or something. It would give those numbers that the size function was. Now column vector, same thing. So if I did A equals 3, 6, whatever I want to do there. Okay, there we go. Nice column vector. Size of A gives you 4, 1. So it's 4 rows, 1 column. Size A1 is 4. Size A2 okay, that should be fairly straightforward. Yeah, and you do need sometimes to figure out the size of things in functions. We'll get to that in a later episode. The numel function, it's a function that stands for number of elements, and it returns the number of elements. So if it's a 2 by 2 matrix, it will return 4. If it's a 1 by 3 matrix, it will return 3, etc. So here's an example. So let's show how that works. So we already have this vector A. Let's do numel A. And it returns the number of elements in the array. Let's make a more complicated thing, which we'll go over in a minute. But let's make A equals 1, 2, 3, 4, 5, 6. So this is a oops, what did I do wrong? Oh, of course. 4, 5, 6. Okay, so this is an array with 2 rows and 3 columns. So size of A is 2 by 3, but the number of elements should be 6 because there are 6 elements in that array. So that's the difference between size and numel. So if you want to know if a row vector or column vector, you want to iterate through it, you might use numel instead of size, because then you don't care whether it's a row or column vector. But that's what this is good for. So I just hinted at you can also have rectangular matrices. Basically, a rectangular matrix, a matrix that has more than 1 rows and more than 1 column. Here's an example of a 3 by 3, 3 rows, 3 columns, size A returns 3, 3, numel A returns 9. A matrix with the same number of rows as columns is called a square matrix. You can also, in a script, construct a matrix like was shown here. And you can do it on the command line, but it gets messy. So let's do some. I already showed you some of that, but let's do that one in particular as a demo. Okay, so you can do, let's say A equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have a 3 by 3 matrix, 3 rows, 3 columns. Size of A is 3, 3. Numel A is a 9. Okay, that's fairly straightforward. Natural extension. Like I said, everything in Octave or Matlab or even Scilab is just an array. Conjugate transpose, which we already showed this, but we'll go over this. This operator takes a matrix, switches the rows and columns, called the transpose, and then takes the complex conjugate of each element in the matrix. So for a complex number of the form, a plus iy, what that does is change it to the complex conjugate changes to a minus iy. We'll get to that in a later. For real matrices that just contain real numbers and no complex numbers, this is the same as the transpose, which means switching the rows and columns. This operator has the same precedence as exponentiation, so it's high priority. Again, real matrix is the same as the transpose. Turns a row vector and column vector. Turns a column vector and a row vector. It switches the rows and columns. So let's do this thing again. So we have A 1, 2, 3, 4, 5, 6. It's a 2 by 3. Now if you take a conjugate transpose, it's now a 3 by 2 matrix with 3 rows and 2 columns. What does it do if you had complex numbers? Now you can do complex numbers in Matlab. So I could do something like, okay, A equals 1 plus 3, 1 plus 1i times 3. 1i is the same as the I. So now we've got a matrix with complex elements. And if you do the transpose, or the conjugate transpose, notice that it did swap the values but took the complex conjugate of everything. Now the plus 0i to minus 0i doesn't do anything, but the plus 2i to minus 2i does something. And what this does is you can see that it changes like this 1 plus 2i changed to 1 minus 2i. And if you go across this one, this 2 plus 1i has became 2 minus 1i. And this column became the complex conjugate of this row. This column was the complex conjugate of this row. Is here. The complex conjugate of this row is this column. So that's what the transpose conjugate operator does. It flips the order of the elements so that if you have 2 rows and 3 columns, it'll all of a sudden have 3 rows and 2 columns. And then it takes the complex conjugate. we don't care too much about complex numbers in this part of the course, but we will hit those later. So now we're going to go over the colon operator in a little bit more detail. So we've already seen that you can use the colon operator to create row vectors, because it always outputs a row vector. Here's like this example. It does all the odds between 1 and 7. Go 1 with a step of 2, 7. So the general syntax is start, colon, step, colon, stop, where start is first number, step is what you increment by, and stop is the last number. But if, like I said, if this was like an 8 here, it would return out the same vector, because when you hit the element 7 and you try to add 2 to it, you get a number outside the range. And then this start stop is equivalent to start, colon 1, colon stop. So you might think that 1 colon 5 conjugate transpose would produce a column vector, but it does not. So what happens is this has the same precedence as this was the exponentiation. So it's done first. So it takes the transpose of the scalar 5, which is 5, and then resolves the colon. So the colon operator is lower priority. But basically what you take from this is the colon operator has a lower precedence than the conjugate transpose operator. So if you wanted to create a column vector, you need to use parentheses so that you get the right precedence. And like we've shown before, you can make any increment you want. These can be real numbers. They don't have to be whole numbers. You can go from pi to 2 pi or something in pi over 4 steps if you wanted to, or something like that. So let's show exactly how that works. Okay, so let's do some of these. So let's see, 1 colon 5 conjugate transpose just gives you 1, 2, 3, 4, 5. But 1 colon 5 conjugate in parentheses with conjugate transpose gives you a column vector. So yeah, that tells you you have to be a little bit careful of precedent when you're using these. And that's how that works. So one last thing about the colon operator. You can use the colon operator, a single colon operator, as a general index. So here's an example. If you have a 3 by 7 matrix A, this returns, if you do A2 comma colon, this says that in row 2, give me all the elements of that column. You have those columns. So this is sort of a stand-in for all columns in this case. In this case, you want to see all the, this is a column vector containing the elements of the third column. So the colon can be used that way. Now here's something that returns A2, because there's two elements here and 7 elements here. So it creates a 2 by 7 matrix containing the second and third rows of A. So colon operator just by itself is an index that means to cover the full range of that particular index. Higher dimensional matrices. Okay. It can be, matrix can have any number of dimensions. So this example here produces a 3 by 4 by 8 by 3 matrix. We can't just say, we don't have names for these other, we can say rows and columns, but what are these other things? They're just a number that anyway. So the size function will return the number of elements in each index. So there's 3 here, there's 4 here, there's 8 here, there's 3 here. numel returns basically what's the product of these numbers. And then you can do all kinds of things with these, like these are ways you can get row and column vectors out of the thing. There are reasons you might want to do these things, but we're not going to return to this in this course, but you can do it. We're not, I think we're going to skip the demo on this one. So here are the exercises. So definitely try these. If you don't get them to work, that's okay, but it's not as critical as the one where you had to learn how to execute a script, but I would definitely go through this exercise to try to learn how to do this. That's it for now. Thanks.